All right, our problem of the week. We are going to look at finding our value for K and using what seems like not enough information. So I'm told that the half-life of something is 16 years. Okay, so knowing that we have the amount that we want to achieve is equal to the initial amount times E raised to the KT. Okay, so what we have, remember that E is a number. It is not a variable. And so I've got 1, 2, 3, 4 variables. And well, if I can get just one variable, then I'll be able to solve for it. So I need to know, do I have enough information? So what we do need to look at is the fact that our half-life is 16 years. So I don't really care how much I started with as a specific quantity. What I do want to recognize is that I started with 100%. Okay, so I started with all of it. And then I'm going to go ahead and change that into decimal form. So my full amount that I started with in decimal form is a 1. So this is a 1 times E raised to the, in a second. Well, if I started with 100%, then half of that is 50%. And 50% in decimal world is 0.5. Okay, so this is how I'm going to represent the half-life. So now I've reduced 4 of my variables down to I've just got a K and a T, and K is your constant that we're looking for. Well, I do know that T is 16 years. So I've got 0.5 or 5/10 equals 1 times E to the 16K. Remember that order doesn't matter with multiplication, so I could have written K times 16, or I could write 16 times K. So I'm going to solve for this. Well, any number times itself, or any number times 1 is just itself. So I'm just going to ignore that. That kind of wasted my ink. And now I have that 0.5 is E raised to the 16K. So my variable is trapped up in that exponent. The only way I can get that down is if I use logarithms. Logarithms allow me to drop exponents down as coefficients. So I'm going to take the natural log of both sides. And there's a reason that I'm choosing the natural log instead of the common log. And it's because one of my bases is something that I recognize. Okay, so this is a base of 0.5. This is a base of E. Well, I know that E's and natural logs are friends with each other. They're actually inverses of one another. Okay, so I know that by using a natural log, it's going to make my life a little bit easier. And that's, of course, what I'm looking for. So this in log world allows me to drop my exponent out front as a coefficient. And now, based on my properties of logs, I notice that the natural log of E, remember that's the exact same thing as log base E of E. Okay, we just write it this way. If my base and my argument match, that simplifies to 1. So the natural log of E equals 1. So this now becomes the natural log of 0.5 equals 16 times K times 1. And just like up here, I kind of wasted my ink by writing the 1. I've also wasted it down here because 16 times K times 1 is the exact same thing as 16 times K. So this doesn't matter. Just recognize that the natural log of E is the exact same thing as 1. So now I'm down to one variable that I can get by itself. So I'm going to divide both sides by 16 so I can figure out what my constant is. So the natural log of 0.5, I'm going to get that on my calculator. So the natural log of 0.5, my daughter stole my graphing calculator, so I'm using this one. And that gives me a negative 0.693, blah, 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 whatever. I will not round now. I'm going to round at the end. So this is the natural log of 0.5. What this represents is E raised to this power will approximate 0.5. Okay, so now that I've got that number, I'm going to divide it by 16. And I get negative 0.04332. So negative 0.04332 is going to equal my K value. So now I just need to know what values I'm looking for as far as I'm looking to see how many decimal places we want to do this to. So we want a total, at the end, we want 1 decimal place. Okay, so I'm going to go ahead and use this entire value up here because it does not say to round during the process. So I have a negative 0.043321699, and that equals K. So for my specific model that I am working with, I know that the amount that I will achieve equals the starting amount. I don't know why I just put another equal sign there. Times E raised to the K, which is 0.043321699 times T. So again, I am back down to 3 variables. So this is my model that I'm going to use. So as far as what my K value is, I figured out what K is. So I'm going to come back up here. I use this information to find out K. Now I'm going to answer this question. So how long until I get to 72% of my original value? It should make sense that it should be between 1 and 16 years. Because 16 years, I'm only going to have half of it left. So I'm looking at roughly 3/4 of it left. So let's look at that. I want 72%. So I'm going to change that to a decimal of 0.72 or 72 hundredths. And now this is how much I want is 72 hundredths. I'm starting with 100%, okay, times E to this nastiness up here. And again, we never round during the process unless we are told to. And I was not told to, so I'm going to give me as many decimal places as my calculator will give me. So I'm in the same predicament as I was before. My variable is trapped up in my exponent. The only way I can get that down is if I go to log world. So I'm going to take the natural log of both sides. Again, because I see E. I don't know a nice, pretty logarithm that's going to cancel this 0.72 out, but I know that E and natural logs are inverses of one another, so that's going to help me. So I'm going to take the natural log of 72 hundredths equals, I'm going to write this thing over here because I'm running out of room, equals the natural log of E to the, and now that I am in X or logarithm world, I can drop this entire exponent down out front as a coefficient. So that becomes negative 0.043321699t. Did not have enough room for that. So what did we learn about the natural log of E? The natural log of E is equivalent to 1, so I don't care about that. And now I just want to get T by itself. So I'm going to divide both sides by this, 3321699. Divide by negative 0.043321699. So that's my answer that is still sitting in my calculator. So I have at this point the natural log of 0.72. So the natural log of 0.72, get that answer, and then divide it by negative 0.043321699. And I get it for an answer 7.58. I'm supposed to round it to 1 decimal point. So I've got 7.6 years. So knowing all of that information, I find out that I'll have about 72% of my product, whatever it is, left after 7.6 years.